All right, guys, let's go ahead and read the section in our book on the lunar eclipse. Go ahead and highlight lunar eclipse in pink, the title there, and then scroll down and you'll see where we are going to end at this pink line. And then go ahead and highlight tides in blue. That will be our next video. And then that finishes up the lesson, and there is your vocab. Okay, so blue for tides, go ahead and put your line there, and then pink here, okay? All right. Just like the moon, Earth casts a shadow into space. Because remember, a shadow is going to be from the sun. So the sun is shining, and it's all going to be casting a shadow, okay? The moon does, the Earth does, all the planets, because of the whole idea of a shadow that we talked about in the previous lesson. So just like the moon, Earth casts a shadow into space. As the moon revolves around Earth, it sometimes moves into Earth's shadow as shown above. So let's highlight here. A lunar eclipse occurs when the moon moves into Earth's shadow. During a lunar eclipse, the Earth is in line between the sun and the moon. The lunar eclipse can take place only during a full moon. So with our lunar eclipse, our placement here is sun, Earth, moon. Okay? Like the moon's shadow, Earth's shadow has an umbra and a penumbra. You can see that marked here. So the darker part here is our umbra, and our lighter part here is our penumbra. There are different types of lunar eclipses depending on which part of Earth's shadow the moon moves through. Unlike solar eclipse, all lunar eclipses can be seen from any place on Earth where it is nighttime. So let's go ahead and highlight that. Because remember, during a solar eclipse, because the moon's shadow is so small and that umbra is so small, covering only just a little part of the world, that's the only place you're going to be able to see it. But since the Earth casts such a large shadow, then you're going to be able to see the moon from anywhere when it's nighttime, okay? All right, so we have a total lunar eclipse. When the entire moon moves into Earth's umbra, a total lunar eclipse takes place. So when we're right here, let's make that a little bit darker, right? Okay, so maybe right here. If we're completely in the umbra, then we have a total lunar eclipse. During a total lunar eclipse, the moon's appearance changes slowly as it moves. So it's going to move first. So it's going to look normal when it's out here, just its normal white, all right? But then as it moves into the penumbra, it's going to look a little bit different. And then it's going to go into the umbra, and then it's going to go back out into the penumbra, and then back on its merry way, okay? All right, so during a total lunar eclipse, the moon's appearance changes slowly as it moves into the Earth's penumbra, then into Earth's umbra, then back into Earth's penumbra, and then completely out of the shadow. You can still see the moon when it is completely in Earth's umbra. Earth blocks most of sun's rays. Some of the rays, however, deflect off Earth's atmosphere and into Earth's umbra. We're going to highlight that. Some of the rays, however, deflect off Earth's atmosphere and into the umbra. The reflected sunlight has a reddish color and gives the moon a reddish tint during a total lunar eclipse. All right, so let's go ahead here and change this to a reddish tint. Okay, reddish orangish tint. The deflection of some of the sun's rays also explains why you can see the unlit part of the moon on a clear night. Astronomers often call this earth shine. Partial lunar eclipse. So a partial lunar eclipse happens when only part of the moon passes through Earth's umbra. This part of it. The stages of a partial lunar eclipse are similar to those of a total lunar eclipse. The difference is that the moon is never completely covered by Earth's umbra. The part of the moon in Earth's penumbra darkens slightly. The part of the moon in Earth's umbra appears much darker. So it would maybe be just kind of catching it out here maybe. Okay. All righty. Why don't lunar eclipses occur every month? Lunar eclipses can occur only during the full moon when Earth is between the sun and the moon. Like solar eclipses, lunar eclipses do not occur every month. The moon's orbit is slightly tilted in relation to Earth orbit. During most full moons, the moon is slightly above or slightly below Earth's penumbra and doesn't go straight through. Okay? All right, so we are at our line. So let's go ahead and take a look at our notebook. Okay, so I have it filled out already. So remember with this, we stop the video and type so that you get it all in, okay? So the definition, and this time we're talking about a lunar eclipse, okay? So the definition occurs when the moon moves into Earth's shadow. It can only occur during a full moon. A total eclipse is the entire moon passes through Earth's umbra. And a partial eclipse is only part of the moon passes through Earth's umbra. So I have made an attempt here at a drawing. So we have the sun and the Earth, and then the moon we're going to draw in. So we have two parts of our shadow. We have the umbra, the darker part, and then we have the penumbra, the lighter part. Okay, so then we have the moon's orbit, okay? So it's doing its orbit. So that's what this dashed line is. So when the moon is out here, we're not in an eclipse yet, okay? When we are here in just the penumbra, okay, we're going to start to change things a little bit, but when we are in the umbra here, it's kind of out of line, sorry about that, that's when we have a total lunar eclipse. And then our partial lunar eclipse is going to be when it passes partially through. Okay, so you're going to be kind of something along this. So then it's going to continue on its orbit through and around and then eventually leave. So this could take, a couple of hours compared to a solar eclipse that only takes 7 minutes or so, because the Earth is casting a much larger shadow. And the moon is so much smaller, it's going to take longer to get through that shadow, okay? All right, so why can you see the moon during a total lunar eclipse? That is, some of the sunlight is deflected by Earth's atmosphere into Earth's umbra. The moon will look orange-red, and it's mostly the longer wavelengths of the EM wave. So it's the red that's deflected in, and so that's why we get that reddish-orangish color. So go ahead and get all of this typed in. All right, stop this video if you need and get it filled in, and the next video will cover tides. Okay,